probability. Probability is the likelihood of something happening. And the value for probability is from 0 to 1. So that's the assigned value for probability. And you can also match this when you say 0% probability, so that would be false, and true for 100% probability. In logic, true is binary 1. Yeah, false, it's a 0. So that's the binary equivalent for true and false. Now, probability has this middle part. So it means this one could be half true or half false. So it says 50% probability. And you can go up or you can go down. So that area there, we play, and the area on the top, we play with that. So from, again, 0% to 100%. And the assigned value, that would be from 0 to 1. Okay, so there's no probability more than 1. So that's the maximum. If you get 1, that's actually the 100% probability. You can also change your 100% into a decimal value. That's the equivalent to 1 here. 50%, 0.5, that's actually equivalent to 1/2 in fractional form. So probability can be represented in decimal form and in fractional form. So we have here some technical terms and definitions for each. Let's say you have to use the word experiment. So we always encounter this word in this section. Experiment is any occurrence for which the outcome is uncertain. And then we have the S here, or the sample space is the set of all positive outcomes of an experiment. So set of possible outcomes, and it's denoted by the letter S. Event is denoted by E, is any subset of a sample space. Sum of the theoretical probabilities of all possible outcomes is 1. Again, this is the most or the highest value for probability is 1, and the lowest is 0. Okay, and we have actually two types of probability. We have the theoretical probability, and the other one is empirical probability. So for the theoretical probability, its probability of E, that is your event, is equal to the number of outcomes in event E over the total number of possible outcomes. Total number of possible outcomes. So this is the formula. So you can have the cardinality, which is n, of your event, and the cardinality of your S. which is the sample space. Okay, so that's the formula. And let's analyze an example here. Okay, a die is rolled once. Find the probability of rolling 3. Remember, a die has 6 faces. Okay, so why is it we have 6? Because that's a cube. And then we're asked to find the probability to get a 3 here. So using our formula for A here, probability of getting a 3 when you roll the die, you will have the cardinality of your E over the cardinality of the sample space. So E here is the event, S is the sample space. So you can only have 1 3, right? So 1 over. And the sample space for the die would be 6. So we have 6 faces there. So 1 over 6, it's the answer for the probability. You can change that into a decimal value or just leave it as a fraction, like that to be exact. Okay, so let's go for even probability. So for you to get an even number, okay, so remember the sample space here, it's in a set. You have 1, that's 1 face, second, 2, 3, 4, 5, 6. So we have 6. So when you see even number, we only have 2, 4, and 6 here. So if you count, that would be 1, 2, 3. So there are 3. So plug that in on the top, you'll have 3 there. And the sample space is 6. So it gives you a 6 here. Reduce that 3 over 6. You divide 3 on the top and 3 at the bottom. So you can reduce the fraction. So the answer would be 1 over 2, or 1/2. That's the probability to get an even number when you roll a die. Okay, so next example. You are dealt 1 card from a standard 52 card deck. Find the probability of being dealt a king. So you are trying to get a king here, and you have to count how many king outcomes you have in a 52 card deck. So probability of getting a king here would be, there are 4, right? Kings in a 52 card deck. So 2 blacks and 2 red. So that would be 4 over 52. And then we reduce this by dividing 4. And then we will get the answer. 4 divided by 4 is 1. 52 divided by 4 would be 13. So that would be the probability of getting a king from the standard 52 card deck. Okay, let's go for the second one, letter B. We're thinking about a heart here, and you know there are four types inside the 52 card deck, right? So one of those would be a heart, and probability of getting a heart would be, there are 13, right? We divide 52 by 4, that would be 13 because there are four types there, over 52. So that's the total number of cards. And then we reduce that by dividing 13 at the top and 13 at the bottom. So always reduce your answer to lowest term. 13 divided by 13 is 1. 52 divided by 13 would be 4. So the answer would be 1/4. So that's how you use theoretical probability. Okay, next would be the second type, which is empirical probability. So it says here, applies to situation in which we observe how frequently an event occurs. So here's the formula. The top would be the observed number of times. E means event occurs, divided by the total number of observed uh, occurrences. Okay. Occurrences. I'll just put it at the bottom. Okay, cannot fit on our board. I'll just put it at the bottom. Observe occurrences. Okay, so it is just, it's up to you how many observed numbers of times the event occurs, and it's up to you also the number, the total number of the observed occurrences. The more, the better. So you can have a really close uh, uh, answer to the right probability. So again, the number or the total number of observed occurrences. Okay, if you have that in a larger number, or you can have that in bigger value, then you have a chance to have a really uh, close answer for the probability. Okay, that could be a true statement. Okay, so the more, the better. Okay, let's try the example for empirical probability here. So as you can see, there is a table. So this is the one, it's like you're doing a survey, you're actually getting an information from a real population. And then you list all of those information in a form of a table. So we have the table as given. If one person is randomly selected from population described above, find the probability that a person is a female. You're looking at a female. So when you're working with that, the probability for female would be the number of females here, 124, divided by the total. So that would be the probability, which is 242. Okay. If you change that into the decimal form, you get 124 divided by 242. It gives you 0.51 in two decimal places. So it's about 51%. So if you change that into a percent, or you can reduce the 124 over 242 into a fraction. So by dividing 2 on the top and dividing 2 at the bottom. So we will do that. So we'll get 62 on the top. And then 242 divided by 2 will get 1 to 1. So that would be the reduced form. Again, we always reduce our answer. So you can have this as your answer, or you can have this. Okay? So that's the problem there. What if you're asked to find the probability of a male? So a male, it's 118 here divided by the 242. So that will be your answer. So if you're asked to find the probability of male, just additional actually question. So but our question is we're looking for the female a while ago, and we have the answers already. For the male, we will get 118 divided by 242. Dividing 2 on the top, so that would be 59 over 242 divided by 2, so that's 1 to 1. So that would be our probability for the male. So if you have that in decimal form, that's 118 divided by 242, or you can say 59 divided by 121. Okay, so we'll give you a decimal value, which is actually in decimal form 49%, or 0.49 in decimal. That's 49% plus 51%, that's 100% total. Okay, so that's how you check your answer also. You can also say 0.49 plus 0.51, it gives you a 1, because the maximum value for probability is 1. And we're only talking about male and female here, so the total would be 242. So it should be summed up to a value of 1. Okay, so that's computing empirical probability. So again, there are two types, theoretical and empirical probability. So it depends on which one you're going to use to display the probability of each of an item.